welcome to my channel Match with Lazy Bee. In this video, we'll be discussing the question of conic sections which has been asked in JEE Advanced 2024 Paper 1. So the question says that x square by 9 plus y square by 4 equals to 1 is an ellipse. And we have a point S P comma Q. We have a point S P comma Q given in the first quadrant. So the point is given in the first quadrant. Point S is given in the first quadrant. So there we have three cases. Either the point is lying in the ellipse or on the boundary or outside the ellipse. Okay. So if it lies on the boundary, it is given by the equation of ellipse x square by 9 plus y square by 4 equals to 1. If it is lying inside the ellipse, so it is given by the inequality x square by 9 plus y square by 4 less than 1. If it is lying outside the ellipse, then it is given by greater than 1. You can check it. You can take a point, for example, origin. You substitute in the equation of ellipse, you get 0 less than 1. So less than 1. So the point lying inside the ellipse satisfies the inequality x square by 9 plus y square by 4 less than 1. And outside the ellipse, the points lying outside the ellipse satisfy the inequality greater than 1. Okay. So by saying that the S point satisfies P square by 9 plus Q square by 4 greater than 1, they make it very clear that the point is lying outside the ellipse, not inside. Point is not inside, it is lying outside the ellipse. So it is somewhere here. Here. Now they say that the two tangents are drawn from S to the ellipse, of which one meets the ellipse at one endpoint of the minor axis. The ellipse is here, this x square by 9 plus y square by 4 equals to 1. This is 3 square, this is 2 square. That means major axis is there on the x-axis and the minor axis is on the y-axis. Because 3 is greater than 2 and 3 is the denominator of x square. 3 square is the denominator of x square. So we have vertices lying on the major axis and the co-vertices lying on the minor axis. So the endpoints of the minor axis is on the y-axis. So the endpoints are 0, 2 and 0, minus 2. We are talking about the tangents. Now, the tangent on the vertices, tangent at the ellipse on the vertices, at the point vertices or the co-vertices are nothing but the horizontal lines or the vertical lines. I have drawn it using purple color. You see, the tangent drawn up at the curve has the slope as the same as the slope of the curve, which is taken in reference. So you see here, if you move close to 0, 2, the ellipse is becoming flat on the top. It's very flat on the top, and the tangent also shares the same thing because the tangent slope is same as the slope of the curve at that point, which is ellipse. And when you approach 0, 2 on the ellipse, you track ellipse on near the point 0, 2, you see that the ellipse is becoming very flat. So that means the tangent line at that point is nothing but the horizontal line itself. You can also see it using the graph. I can show you. Share. Desmos. You can see, if you take this point 0, 2 and you zoom, you'll see that the ellipse is shown in the orange color. The ellipse is becoming flat on the top. You see the line y equals to 2 and the ellipse are very close. And when we zoom, they're so close that we're not able to even differentiate. They don't touch each other. It is almost horizontal. It is not exactly horizontal. It is almost horizontal. The ellipse becomes almost flat. So I am just trying to show you that the ellipse is becoming flat, and that is the reason the tangent line has the same slope as the curve. So the tangent is nothing but the horizontal line y equals to 2. You can also see this by calculating. Okay, so the equation of the ellipse is given by x square by 9 plus y square by 4 equals to 1. Now, how do we obtain the slope of the tangent line? We use derivatives. So we will differentiate this equation with respect to x. So we will get 2x by 9 plus 2y by 4 dy by dx equals to 0. Now we are considering which point, 0, 2 or 0, minus 2. So in both the cases, we have x equals to 0. So substituting x equals to 0 and y equals to 2, you get dy by dx is nothing but 0. Dy by dx is nothing but 0. This implies the slope of the tangent line has slope 0. That means it has to be the horizontal line. You can also integrate the equation and you get y equals to c, where c is a constant. To obtain the value of constant, you substitute the initial condition y0 equals to 2. So x is nowhere, so you get c equals to 2. This implies y equals to 2. This is the equation of the tangent line, y equals to 2. This is the tangent line. And similarly, at the point 0, minus 2, tangent line will be y equals to minus 2. Minus 2. If you check this for the points vertices with 3, 0 or 0, minus 3, 0, minus 3, sorry, 3, 0 or minus 3, 0, then you'll get the vertical lines are the tangent. You can follow the exact same method and you'll see. Okay. Now, since we have figured out the tangent lines at the co-vertices, that is the endpoints of the minor axis, now this will help us to find out S. Ultimately, we have to find out the P and Q. So, we will be breaking the question into parts. Okay. Now, S is lying in first quadrant, and the other endpoint of the minor axis 0, minus 2 is lying in the fourth quadrant. So, do you think it is possible for S to lie on this line? Because the tangent line is this, y equals to minus 2 line. And S is lying in the first quadrant. Since the tangent line passes through S or is drawn from S, so that means S is also lying on this tangent line. But the tangent line only has points lying in the fourth quadrant or third quadrant, and our S is lying in the first quadrant. That means the point taken in consideration is not 0, minus 2, it is actually at 0, 2. Because S is lying in the first quadrant. S is not lying on this line, y equals to minus 2. It is not in the fourth quadrant, it is lying in the first quadrant. So we have figured out that point is 0, 2, not 0, minus 2. Now this will help us to find Q. Okay, the tangent line is this, y equals to 2. Point is 0, 2. Tangent line is y equals to 2. So tangent line is the horizontal line, y equals to 2. So horizontal line, any point lying on the horizontal line has all the points lying on the horizontal line, if I say, have the same y coordinates, y equals to 2. The point lies here. S is also lying here because the tangent line passes through S. The tangent line is horizontal, that means S is lying on this line only. So it is either this is either this. So whatever it is, whatever the x coordinate is, x coordinate varies on the horizontal line, but the y coordinate remains fixed. It is fixed. So since the line is y equals to 2, that means the y coordinate of s is also 2. It cannot be anything else. It is lying on the horizontal line. Y coordinates remain same. When we are talking about horizontal line, any point on the horizontal line has the same y coordinate. So y is fixed. So q is nothing but 2. Fine, q is fixed. So q equals to 2. We have found out. Now we have to find out p equals to, what is p? P equals to question mark right now, because we don't know what is p. Now we have q equals to 2, so that means it is clear that c and d are out of question, because in both the cases we have q equals to 1, q equals to 1, which is not the case. So now we have to find q equals to 2. So now we have to find p. We have found q equals to 2, because we have to find the coordinates of s. Now the other thing which is given in the question is the other tangent meets the ellipse at a point in the fourth quadrant. So the point s could have been here, anywhere on this line, horizontal line. But notice that it cannot be very close. For instance, if I take s is lying here, then will I be able to draw a tangent of ellipse like this? If I draw any line passing through this point S, then it has to intersect the ellipse at 2 points. So so we are able to find that S is not that much closer to the ellipse. It is a bit far away, because if it is very close to the ellipse, then then it is not possible to draw the tangent. The line is bound to intersect the ellipse at 2 points. So that means it can be somewhere here, it can be here or a bit far, but not very close to ellipse. Okay, so I took a random guess right now, and I said that let S be here, and I drew a tangent from this point to the ellipse. So this is T. This case is not going to affect our calculations. This is just for the sake of drawing the graph and to be able to show you how the things look like when we are actually plotting this on the graph. Okay, so this is T, and there are some namings given. This is R, the vertex of the ellipse with positive x coordinate. So this is R. Vertex is the endpoints of the major axis, and since the x coordinate is given to be positive, this is R, 3, 0, and O is given. This is the center. And one more thing is given, that the area of the triangle. So draw the triangle. This is the triangle, and you see that area of the triangle is nothing but 3 pi by 2. This is given in question. How do we find out the area of a triangle? We usually use half into base into height. Now the base is OR, and you draw a perpendicular from T to OR. This is TB, perpendicular first to TB. And what is OR? 3, the length of the semi-major axis. Major axis is complete. So semi-major is half. So this is nothing but 3. And we substitute this value in the question, you get height equals to B, T equals to 1. Because this is 3, so it will get cancelled by the right hand side, and you get height equals to 1. Okay. We don't know T right now. So, but we know that the line joining S and T is a tangent line. So if we know the equation of the tangent line, then and we can calculate the slope of the tangent line as well. How? First, let us find the slope of the tangent line. Then we will move further. So if we find the slope of it, how do we do that? I have already discussed that in the early part of video. This is x square by 9. This is the equation of ellipse. To calculate the slope of the tangent line, what do we use? We use derivatives. So differentiate this equation. Sorry, this is 0. This implies dy by dx equals to minus 2x by 9 upon minus 2 by 9y. So this is not minus, and you can cancel this 2. This is 4. Sorry, this is 4, and this becomes minus 4 by 9 and x by 1. So the slope of the tangent line at any point of ellipse is given by this. Okay, so once we know the coordinates, substituting the coordinates here, we can find out the slope of the tangent line of the ellipse. Okay, now since we have to use this also, triangle ORT, area of the triangle ORT, and we also have to use the tangent line, because S and T are connected by the tangent line. We can find the slope at T. We can find the slope at T using this equation. Let me move it. Okay, so I'm going to move like this. So we have the slope of the equation. Sorry, slope of the line of the tangent. This is minus 4 by 9 x by y. Just substitute t, coordinates of t, but we don't know t right now. We don't know t. So if we assume t to be some a comma b point, and we substitute, we are going to get two variables. Here it will be a, and here it will be b. And if we try to find out the equation of line using the form y minus b upon x minus a, because it passes through t, and the slope is given by minus 4 by 9, and this is given by a upon b. So we'll be having two variables, both unknowns. We'll be having two variables. So this is not going to give us anything. So, but we have equation of the tangent line. We can find the equation of the tangent line using a parametric form as well. The parametric form of the ellipse is given by 3 cos t and 2 sin t, where t is lying between 0, 2 pi. You start from the positive x-axis, you keep on moving, and by tracing the entire curve, you get back to positive x-axis, then the angle is 2 pi. So you don't need to include 2 pi again and again. Since we have already included 0, you can easily avoid 2 pi. So any point on the ellipse is given by 3 cos t, 2 sin t, where t is lying between 0 to 2 pi. Now, the best part is that parametric form gives only one unknown variable. Here it is t. And since the capital T is lying on the ellipse, that means we have some theta lying between 0 to 2 pi, such that t also has the form 3 cos theta and 2 sin theta. So the thing is that we don't need a comma b, we have only one variable, one unknown variable. Since we don't know t, we don't know theta. Once we know theta, we are able to figure out t. But the parametric form gives us only one unknown variable. We don't need two, a comma b. We just need one. We just have one unknown, which makes the solution easy. Okay. Now, since that is this, and we substitute that points t in this equation, we will get y sin theta. You solve it. You substitute 2 sin theta equals to b, a equals to 3 cos theta, and you cross multiply, you get y sin theta upon 2 plus x by 3 cos theta equals to 1. This gives the equation of the tangent line. This gives us the equation of the tangent line. Now, since S is also lying on this tangent line, and we know that the x coordinate is p and the y coordinate is 2, substituting it here, you get 2 sin theta upon 2 plus p upon 3 cos theta equals to 1. Okay, now once we are able to find out theta, we are able to find out p. How to find theta? One part of the hypothesis is unused right now, which is the area of the triangle. So we found that the height BT equals to 1. Now the reason for drawing the perpendicular through T only was that now here we can use the y coordinate of T, because the length of the perpendicular is nothing but the modulus value of the y coordinate of T. Since we are taking length means the positive value, so y coordinate is negative here, so we'll be taking the modulus, nothing, no problem. So this means BT equals to modulus of 2 sin theta, which is nothing but 1. Since theta is in the fourth quadrant, this is theta. This is theta. Fourth quadrant, so sin theta's value is going to be negative over here. This implies minus 2 sin theta equals to 1, implies sin theta equals to minus 1 by 2. This gives 30 degree in the clockwise direction. 30 degree in the clockwise direction. So when we calculated anti-clockwise, you get 2 pi minus pi by 6, which is nothing but 11 pi by 6. So this is the value of theta. Substituting this here, sin 11 pi by 6 plus p by 3 cos 11 pi by 6 equals to 1. This is minus half plus p by 3. Cos is positive in the fourth quadrant, so this is same as cos 30 degree, cos pi by 6, which is nothing but root 3 by 2. So solving for p, you get p equals to 3 root 3, which is the final answer. And as calculated earlier, q equals to 2. So the coordinates of S are given by 3 root 3 and 2. So A. I hope I have explained you the question properly, the answer the solution properly. So if you feel any doubts, you can ask me in the comments. And thank you so much for watching my video. Happy learning and see you soon.